Welcome to Homework Lib.
Question, we have a little bit of a trick because your professor gives you data in order to calculate the enthalpy for the reaction coming from calorimetry, but the delta H for the combustion corresponding to C5H8 plus 7 of oxygen producing 5 CO2 plus 4 molecules of water, all of this in gas phase, is given to us. The delta H for this reaction is equal to minus 3068 kilojoules per mole. Other information that is given to us in our problem are the delta H formations for different compounds. So, for example, over here we have the delta H formation for oxygen, that is 0, for CO2, sorry about that, which is going to be minus 393.5 kilojoules per mole. Let me put it over here, kilojoules per mole, just to put it all together. And the one for water, that is going to be equal to minus 241 kilojoules per mole. 0.8 in this case. Sorry about that. So we don't need to do any further calculations. We can go ahead and directly employ Hess law. So Hess law tells us that the delta H for the reaction is the sum of the enthalpies of the products minus the enthalpies of formation of the products minus the enthalpies of formation of the reagents multiplied each of them by their stoichiometric coefficient. So in this case, delta H of the reaction would be equal 5 times delta H of formation for CO2 as a gas plus 4 times delta H of formation for water as a gas minus delta H of formation of C5H8 as a gas as well, minus 7 times the delta H of formation of oxygen gas. So we're asked to calculate the enthalpy of formation for this compound, so we need to isolate this value. In this case, we simply need to substitute the results. So just to simplify it a little bit, we know that the enthalpy of formation for oxygen is going to be equal to 0, so we can directly say that the delta H of formation for C5H8 is going to be equal to 5 times the enthalpy of formation of CO2 plus 4 times the enthalpy of formation of water. I'm going to omit the phases just to keep notation a little later, minus the delta H for the reaction that is given to us. So, replacing the values, delta H of formation for the desired compound, C5H8, is going to be equal to 5 times minus 393.5 kilojoules per mole plus 4 times minus multiplied by minus minus 241.8 kilojoules per mole. And finally, the delta H for the combustion, which is minus 3068 kilojoules per mole. So this is going to give us an enthalpy of formation equal to 133.3 kilojoules per mole. Let me put it extra clear that this is the enthalpy of formation of the compound that we desired. So this is enthalpy of formation of C5H8. So with this, the problem is solved with the data that was provided. Just a warning here, in the case that the enthalpy of the combustion was given to you directly in kilojoules, then that would mean that that represents the enthalpy corresponding to burning the 0.1063 grams of C5H8. In this case, since that information is already in kilojoules per mole, You already know that that is the enthalpy for the combustion reaction, for the ones that we have here. So that would be all. Thank you very much and have a good one.